Xylaria polymorpha, colloquially referred to as dead man's fingers, is a species of fungi found here in the northeast United States and in other areas as well. That's very often posted on mycology subreddits and Facebook groups for identification due to its long, black, finger-like projections from which it derives its namesake. It can, if it grows the right way, resemble the fingers of the undead reaching out of the soil to grab an unassuming hiker's ankle on their morning stroll through the park. It is for their very unmushroom-like appearance that I find them interesting, and decided to do a deep dive into these mushrooms and really try to give a deeper understanding of this fascinating species and genus and their morphology and their reproductive structures, etc. So it is important to state that the Xylaria genus are a genus of Ascomycetes, meaning they are part of what's called the sac fungi, so called because their fruiting bodies form cup-like sacs called ascocarps to grow their spores in. Now within these ascocarp structures are what's called asci, which are essentially small tube-like structures that hold 8 ascospores, each of which can germinate into a hypha, and then a mycelial mass, which can potentially reproduce and form another ascocarp in the correct conditions. The Perithecia genus are mushrooms that are pretty popular on mycology Instagram posts because they use wind energy to transmit their spores, and thus if you blow on them and wait a second or two, you'll see an explosion of spores shoot out of the fruiting bodies. Perithecia mushrooms are ascomycetes, and so are the delectable and much sought after morels that we hunt every spring. And if you zoom in on a morel fruiting body cross-section, it would show you that morels indeed have these 8-spored asci sacs as well. European truffles are also an ascomycete fungi. The ascomycetes are distinct, of course, from the club fungi, also known as the basidiomycetes, which do not have sacs of 8 spores, but 4 basidiospores housed in structures called a basidium, attached to sterigmas. So notable examples of basidiomycetes are oyster mushrooms, amanita mushrooms, boletes, etc. So if you were to stumble upon these dead man's fingers and you had no idea what type of fungus it was, and you have access to a microscope, you can then look at a cross-section of the fruiting body and look for spores, and if you see bundles of 8 ascospores, you know at the very least that they're ascomycetes and not basidiomycetes. And in a second, we're going to do just that. We're going to take a look at a cross-section of Xylaria polymorpha under a microscope and see what we find. But first, we need to talk about the general shape and morphology of the Xylaria genus. So specimens of the Xylaria genus usually present as having club-like fruiting bodies that are covered with a rough black surface at maturity. Before maturity, they can often display a bluish tint, and that is because the Xylaria genus can reproduce both sexually through its ascospores, as I mentioned before, and asexually through what we call conidium that make conidiospores. And the blue color is present during immaturity because only asexual reproduction happens during immaturity, and the asexual conidiospores are bluish in color. Slowly but surely, though, the fruiting bodies change color to a dark jet black color, and thus by simply looking at the color of, for example, Xylaria polymorpha, we can tell at what stage of sexual development the fruiting body is at. Now, in addition to the dark club-like fruiting bodies of the Xylaria species, a cross-section reveals that a large part of the interior of the fruiting bodies are a pale white color. And on the borders of this pale white section, you can see a thin layer of the actual black material that is present on the outside of the fruiting body. Now, that white material is referred to as the stroma, but those dark circular shaped sections that form the outer layer of the fruiting body, or the ascocarp, if you will, are called the perithecia. And it is here that the asci are held. And within those asci are each 8 individual ascospores. And I'm going to go more into detail in other videos about ascomycete reproduction and exactly how it happens. There's a process kind of a modified haplontic life cycle, but we'll get into that in more detail in another video. But what you should know, I guess for this species right now, is that every perithecia also has a terminal hole called an ostiole that the asci secrete their ascospores through one by one. And this is one of the most interesting behaviors the Xylaria genus display, is that the asci, or the ascus in the singular, slowly, over the course of sometimes months, release their individual spores in a time-released fashion, as opposed to, let's say, a basidiocarp oyster mushroom, which releases its spore load in its entirety over the course of a week or even a few days. And this may be an evolutionary strategy to maximize its chances of reproduction by the Xylaria genus by producing spores in many different environmental conditions correlated with the changing of the seasons. So let's take some closer looks here. So what we're doing here is we're taking a closer look at a slide that I mounted of the Xylaria polymorpha fruiting body. And we can see that from left to right, you see this long stripe. And that is, in fact, the outside of the ascocarp, the kind of rough black material. And these circular bodies within that are the perithecia that I mentioned earlier. And it is within these spots that we are going to find our asci, which contain, of course, the ascospores. So I kind of want you guys to get yourself oriented and kind of realize where you are. I'll kind of put some visual aids in there for you guys. Of course, the white yellowish portion is the stroma, but we're going to continue panning. And on the left here, it seems that I cut a perithecia open on accident, and that provides ample opportunity to kind of boost our magnification and see what's going on in here. So we're going to do that, and I'll resolve this view here in a second. And you're going to start to see that the spores are coming into view. And in particular, if you look at the bottom left-hand corner, you see kind of a sausage link shape of spores, kind of a semicircle of conjoined spores. And that, my friends, is the asci. That is the ascus. I guess the singular is the ascus. And that has about, you can't really count them here because the frame cut it off, but that has about 8 ascospores joined together, and they will exit through the ostiole of that perithecium. And I just find it fascinating that, just with a microscope, we can start to really visualize and experience these reproductive structures and these spores and kind of see how they work and the mechanisms of how it happens. So I'm really excited to be able to find that, view that, and kind of share it with you guys. But yeah, so these are the spores. They kind of have these, they look like almost like black bananas to me. Another really interesting feature of the perithecium that I found while I was exploring was this kind of ridge-like portion of it where there's a bunch of mycelium and some spores. And if you look closely, you see some mature spores, but you also see spores that are immature, and you can tell those by the fact that they have these kind of droplets in them, these circular objects in them. And those are called gutules. They're essentially lipid storage structures. And they have all sorts of really cool and interesting functions. But you can see, if I zoom in there, that each one of these ascospores that are not dark black in color have a round droplet in them. And so these are just the amazing and interesting observations that you can make while exploring the world of ascospores. So I think that's really cool, and I'm glad that you guys tuned in. And if you like these kind of videos and this kind of content, stay tuned, because there's plenty more to come.